Hello.
Hello, Mary. Hello, Guillaume. I hope you're both well.
Yes.
Yes.
So this one is a dual act, actually. So it is a joint presentation by Mary and Guillaume, and they're both from Encres DUBUIT, and they'll be telling us about inks based on cellulosic materials for flexible, conformable, and stretchable printed electronics. So whenever you're ready, please do share your slides. So we can see your slides, and the stage is yours, and good luck.
Okay, thank you. So I'm Guillaume Krosnicki from Encres DUBUIT. With Marie Goizet, who will present you our work about cellulosic materials for flexible, conformable, and stretchable conductive inks. First, some words about our company. Encres DUBUIT developed and manufactured special ink for industry since 1954. We are a worldwide company, and since 7 years now, we developed and manufacture ink for printed electronics. We have now a large portfolio of ink for printed electronics. We have silver conductive inks for in-mold electronics and antenna, for example. We have also carbon inks for heaters or capacitive touch panels. We have ink for electrochemical sensor or electroluminescent display. But today, I would like to focus on two different kinds of inks, transparent conductive inks and stretchable conductive inks. These inks are needed in many fields in printed electronics. We need stretchable conductive inks in, for example, wearable devices like smart textile for sport or patches for biomedical applications. And in the other end, we already find transparent conductive films in many devices like displays or OLED. And with printed electronic processes and the help of transparent conductive inks, we can improve the deposition processes of these transparent conductive films because printed electronics is mainly additive processes, and we can also increase the flexibility of these devices. So these inks seems very different, and they are very different, but in Encres DUBUIT, we use the same materials as basis to develop and manufacture these both inks. In fact, we use nanocelluloses in these inks. So nanocelluloses are a derivative from cellulose, so from wood. With different processes, we can extract cellulose fibers and then elementary fibrils from this cellulose. And we obtain two different nanocelluloses. First, crystalline parts named cellulose nanocrystals with very short form factor. And cellulose nanofibril, which is composed of amorphous and crystalline parts with long form factor. In Encres DUBUIT, we use these cellulose nanofibrils in some of our inks because it's a derivative from cellulose. We can say it biobased, renewable, and biodegradable. It is also a biocompatible material, which can be very useful for some application, like in medical fields. Depending on the grade and the quality of these nanofibrils, it can be a very transparent material. And thanks of some of their properties, the high aspect ratio, the high affinity with water, and the high cohesion, these nanofibrils can be used as a very strong dispersing agent in inks. We have also the possibility to modify the chemistry of these nanofibrils, the chemistry of the surface, in order to get new properties. Thanks to all these properties and the possibility to combine these cellulose nanofibrils with other materials, we can obtain some composite with synergetic effects. In Encres DUBUIT, we mix cellulose nanofibrils with other derivatives and some additives to make a composite. This composite is a matrix, a transparent matrix, very transparent, and we use it as a dispersing agent in our inks. Thanks to the nanofibrils, this matrix is a very powerful dispersing agent for organic or inorganic